afternoon. Let's start with our first video lecture. The atom is the smallest indivisible unit of pure matter, but is it the smallest particle we can get? There are in fact 3 subatomic particles. Sub means below, like a submarine goes below the water. So this is below the atomic level, hence smaller than an atom. Okay, there are 3 of them. First one's proton, second's neutron, followed by an electron. Okay, you guys got that all written down? Let's start with the king of them all, the proton. It's the most important of the subatomic particles. It resides in the nucleus. It has an atomic mass unit of 1. Also has a charge. It's a positive charge. P for positive, P for proton. That's how we're going to keep those 2 together, okay? Each atom is distinguished or differentiated by how many protons the atom has. Okay, that means I can tell one from another. Hydrogen has 1, helium has 2, lithium has 3. That's just how it goes. I have a certain number of protons, I have a new element, okay? The periodic table that we're learning about and we'll study specifically next unit is actually arranged by the atomic number or the number of protons each atom has. Okay? Protons cannot be gained or lost. They are the king. That's how I differentiate one from another. If protons could be gained or lost, I could turn lead into gold, which people have been trying to do for years. The reason I can't do it is because I can't move protons around. Okay, good? But hey, wait, is an atom an element? Actually, yes it is. Each species of atom is referred to as an element. An atom is really just one unit of a particular element. Does that make sense? Next one, neutron. Neutron is neutral. It resides in the atom's nucleus. N, nucleus. It has an atomic mass also of 1, like the proton. And it's in the nucleus, like the proton. Its difference is, though, it's neutral. So in the side, write that. Neutral. Neutron. Neutral. So does it have a charge? No. Just like the proton has a positive charge and is in a nucleus, this has no charge, just in the nucleus. So not really the same, but a little different. Neutrons can be gained or lost. When I gain or lose a neutron, you get another vocabulary word. It's called an isotope. The electrons reside in the orbital outside of the nucleus. They have 0 mass. I would think of what little mass they do have as a fly compared to the Empire State Building. Very inconsequential. If the protons and the neutrons of the Empire State Building, the electron is so little it's like a fly and its mass is virtually 0. So for our purposes, we're going to call it 0. Electrons can be gained or lost. When we start playing games with electrons, gaining and losing them, we result in an ion. Okay? The electron orbitals expand outward from the nucleus, much like the ring of a tree. So if you've ever seen a tree cut down, and you look at the stump, in the center you'll see a little ring, and then there'll be rings all the way around, expanding outwards. We can actually tell how old a tree is by counting those rings. The layers of electrons are going to expand outwards just like that. Okay? The electrons are the key contributor to things like bonding and building molecules out of atoms and big other structures and reactivity, because they're the ones that are going to be doing the moving and the shaking and the carrying out. Okay, that's where we're going to get that from, is electrons. And now we're done. So there's your first video lecture. Go on to the questions, and I'll see you tomorrow in school.